When I first heard that Hurricane Sandy was barreling towards the East Coast, I actually had just one question. Were my parents in New Jersey going to be safe? So I got online and I found a map. This map. It's a map provided by the Federal Emergency Management Agency, or FEMA. It tells the powerful story of advanced analysis of factors like storm surge, inland flooding, winds, and snow. It tells the story of that analysis, and it told me that my parents were going to be safe. It got into my hands, and it got into the hands of the decision makers. So I started to ask around, how could FEMA have been so successful to create a critical map like this before the storm even hit? What I found out was that they were successful because they were prepared. They were prepared with advanced models ready to run at a moment's notice. They were prepared with web maps that were ready to update with the most current information. They understood the value of spatial analysis, and they took the time to train and learn about the available techniques. And since I'm on the spatial analysis team, I thought I'd take a little bit of time to give you a bit of a crash course in spatial analysis, since it's at the heart of what makes maps magical, and it's what's going to help us really start to answer the tough questions. Now, this crash course is going to take us from very simple methods like overlays to more advanced techniques like interpolation. That way, you'll be prepared to approach every problem with the best spatial analysis that ArcGIS 10.1 has to offer. Our first technique is visual analysis, overlaying, integrating multiple data sets to gain new insights. And it takes us to ArcGIS Online, and data we have for Africa on vulnerability to climate change, leading to things like drought, famine, and disease. What we see is that sub-Saharan Africa has higher vulnerability than other parts of the continent. What if we wanted to understand if the funding going into the continent is getting to the right people in the right places? Well, we can search ArcGIS Online. In this case, we'll look for World Bank projects. We know that the World Bank has a lot of projects that are currently focused on Africa, and we can add that service, which is already shared in ArcGIS Online, right to our map and start to see if the funding is going to the right people in the right places based on this type of vulnerability. So immediately we can see that there's a lot of projects in Africa, and we can dig in a little bit deeper and actually start to see even the breakdown of these projects, starting to really gain new insights. It's a lot more than just spreadsheets, for instance. We can bring all of this data together and start to make sense of it. Let's switch gears to technique number 2, which is about quantifying the intersection of multiple data sets. It's about overlays. This brings us to Yemen, where the governorate of Shabwa is interested in managing their natural resources, including this soils data. What they want to know is what is the area of each type of soil in the governorate. So how do we do this kind of intersection, this kind of overlay? Well, in ArcGIS 10.1, a new tool called Tabulate Intersection does this for us in one simple step. We'll point to our data. Now, prior to 10.1, we would have started by running an intersection. Then we would have done a summary statistics. And finally, we would have been ready to create a pivot table. We've taken this very common workflow and turned it into one simple tool. So with the click of a button, we've walked through that whole process. And now we have the area and the percentage of each type of soil in the governorate. Technique number 3 is about interpolating surfaces from discrete point data. In this case, we have simulated data, simulated sample data in the greater Cairo area on air quality. So how do we turn this discrete point data into an accurate, continuous surface? In ArcGIS 10.1, another new tool called empirical Bayesian kriging does this for us with the simplicity of our most basic interpolation tools and the sophistication of our most advanced geostatistical methods. Now, this looks really simple, and it was really easy to run, but the result is a lot more than just a pretty picture. Because we've taken a statistical approach to interpolation, not only can we look at the prediction surface, we can also look at the prediction error, which will start to give us an understanding of the confidence that we have in the predictions across our study area. The darker red are the areas where we have lower confidence, indicating that we may need to take additional samples in those areas, which takes us to technique 3.5, which is all about spatial analysis everywhere. We'll grab our iPad and head out to the field. We're going to take some additional samples of air quality. We'll add some data. And with the click of a button, we're sending that new live data to a geoprocessing service. It's running that advanced geostatistical interpolation from an iPad. We're putting this kind of advanced spatial analysis in everybody's hands. So now in the field with my live data, I'll be returned the most up-to-date surface based on that sample data that I'm collecting. Now we can see how things have changed, and we can also integrate additional geoprocessing services. Okay, we can see how things have changed, right? And we can also integrate additional geoprocessing services. In this case, we have a watershed service, which will show us the watershed that we're in, as well as compare the air quality for that watershed to the rest of the country. So by integrating these services throughout the organization, across devices, we're really putting advanced analysis into the hands of everyone in our organization. Takes us to technique number 4, which is about network analysis and routing, and not just any routing. This is about the new ArcGIS Online World Routing Service. And what we need to do, we have a couple of stops in the Dubai area, and what we want to do is route between them this afternoon. And we want to route between them so that we can save time and money. So we'll use the Find Route tool, which we've hooked up to that ArcGIS Online World Routing Service. The service integrates advanced network analysis with optimized network data, including worldwide, live, and historic traffic data. Now when we can choose the time of day that we want to route, choose to reorder the stops to find the optimal route, and when we click Find Route, it's going to send all those stops up to ArcGIS Online, where ArcGIS Online is going to do all the heavy lifting, do all that work for us, and return to us the best route based on that live and historic traffic data. And like I said, this is worldwide data. With historic traffic data in 97 countries and live traffic data in 26 countries, routing from Riyadh to Doha to Bahrain to Kuwait City is as simple as just a few clicks. That takes us to technique number 5, which is about finding clusters in our data. And it takes us back to that vulnerability data we looked at earlier in Africa. Now, we know that vulnerability actually has a lot of factors. So we have data on things like poverty, population density, the environment, and government stability. So how do we make sense of all this data? How do we find patterns in this data? I don't know about you, but looking at thematic map after thematic map after thematic map, pretty hard to find a pattern. So a new tool called grouping analysis helps us make sense of all of these variables, finding groups or regions in our data that have similar characteristics. And we can use all of those variables that we were just looking at And what grouping analysis is going to do is it's going to create groups so that within each of the groups, the features are as alike as they can be. And between groups, the features are as different as they can be. So it's trying to create these regions that have very distinct characteristics. And one of the outputs of the tool is a map. It's a map that shows us the spatial pattern of those regions, the spatial pattern of those distinct characteristics. And we can start to make sense of that map. Here we can see that the area in yellow or orange, the major factors of vulnerability have to do with government stability and poverty. We can see that the area in green is a low vulnerability area. The areas in blue, it's more about environment. The areas in red, population density. By understanding the factors of vulnerability in these areas, we are much more able to deal with each of those regions most effectively. Well, the last thing that I want to show you is how easy it is for us to share our analysis using the new geoprocessing package. Sharing our analysis is now as easy as right-clicking on a result, whether it's the result of the simple run of a single tool or our most advanced models, and choosing to share it as a geoprocessing package. And when we hit share, it's going to take all of our input data, all of our output data. If we had models, it would take the models, including any nested models or scripts, put them all into this geoprocessing package, and in this case, it's going to send it up to ArcGIS Online. Once it's in ArcGIS Online, I can share it with relevant groups, and I can start to really contribute to the conversation in a meaningful way. This is going to take about a minute to package, but what I've shown you here are really just a couple of the thousands of ways that we can use spatial analysis to solve problems, to make more informed, data-driven decisions. And you'll see all morning the way that spatial analysis plays a critical role in almost every workflow, from the simple to the complex, from 3D to imagery, and everything in between. Well, that takes us back to FEMA. The analysis that they did ahead of time was critical. But we know that analysis happens at all stages of the decision-making process. It's pretty safe to say that chances are Hurricane Sandy won't be the last hurricane to ever hit New Jersey. And being prepared for the future is essential. A very close family friend called a place just like this home, a place destroyed by storm surge. Many communities are now in the proposal stages of building hurricane barriers to help protect low-lying areas from future flooding. GIS plays a critical role at every stage of that process, from building 3D models to analyze things like the visual impact of those barriers, to gaining acceptance from the community by building realistic 3D models for communication to the community.